Reaction force calculation, uniformly distributed loading situation. So this is called the uniformly distributed load. So previously we have seen that motorcycle chassis weight was given a concentrated load in the middle. In this case we are assuming that it is uniformly distributed at 4.5 pound per inches across the 100 inches long motorcycle. Couple of disclaimer: this motorcycle is about 97 inches length, and obviously the chassis weight will be a little bit heavier in the middle compared to the front and rear. But in this example we are assuming they're all equally uniformly distributed like this. And then how to do the calculation for any uniformly distribution loading situation? Very simple. First step is to do the free body diagram and balance the forces. So these two wheels are carrying all the load of this motorcycle, so we're gonna do a free body diagram, and then we're going to then have to balance the reaction forces in the front and the reaction forces at the front once we free that wheel. So we are making imbalance, so we'll have to apply that upward direction reaction force at the rear and at the front. So that's what you're going to find out. Now very simple, you only have two variables. You take moments with one of the variables, then that variable cancel out because it's passing through the same point. So we're going to take moments with respect to point rear wheel center. So then that will cancel the rear wheel reaction force, and we'll be able to calculate the front wheel loading. And then if you take moment with respect to rear wheel, all these, the passenger weight 250, the 350 rider weight, the engine weight, and also this uniformly distributed load, the total will act exactly in the middle of this motorcycle. So and they all will cause negative moments. If we look at the rear wheel, all these forces will do a clockwise moment. Try to rotate the motorcycle with respect to rear wheel clockwise. So all this will be negative moments. So let's take moments with respect to the rear wheel and sum counterclockwise positive, everything sum to 0. If you take that moment, so it's gonna be simply for that 250 pound loading, that is 7 inches away. The way you can calculate that is the total wheelbase 64 inch, and then you can subtract all these dimension from the 64 inch, then that will give you 7 inch for the passenger distance from the rear wheel. And then that's going to be a negative moment, and then also that 350 rider weight will also cause a negative moment, and that is 7 plus 15, which is 22 inches, minus that distributed load, which is 4.5 pound per inch, and you got total 100 inch long motorcycle, so that's going to be 450 pounds total loading, and that's going to exactly act from the middle of that rectangle. So that is exactly 64 divided by 2 from the rear wheel. So 64 divided by 2 away from the rear wheel, minus the engine moment, which will also cause negative moment, 400 times the distance from the rear wheel, which will be 7 plus 15 plus 17, that I found 39 inches. And then we have also this front wheel loading, which will cause the front wheel reaction force, which will try to rotate this motorcycle with respect to the rear wheel counterclockwise. So it will push here. So it's going to do a counterclockwise moment, which is positive. So then front wheel reaction times the 64 inch away from the rear wheel, everything sum to 0. If you solve for the front wheel reaction force, now I've calculated 616 pound for the front wheel. Now to calculate the rear wheel reaction force, you do the exact same, except you take the moment with respect to the front wheel instead of rear wheel, and you sum everything, and everything will sum to 0. It's statics, it's not rotating in any direction. So now, however, all these with respect to the front wheel, all this external loading, the passenger, the rider, the engine, the chassis, everything will do a counterclockwise movement. So then that will be all positive for that 250 pounds. And then that is, I calculated 57 inches away plus 350, and I calculated that rider is 42 inch away from the front wheel plus 450 chassis, which is exactly going to act at the middle, 64 by 2 plus 400 engine weight, which is 25 inch away, minus the rear wheel. Now the rear wheel reaction will try to rotate clockwise with respect to the front wheel, so that will be a negative moment for the rear wheel reaction force, and then times that is 64 inch away from the front wheel, and everything summed to 0. I calculated the rear wheel reaction force or load carried by the rear wheel is 834 pounds. Now you also have to do a check whether you have calculated correctly or not. So the total external loading was 250, 350, 400, and plus this chassis weight. So the total is 1450. So if you add these two numbers you have calculated, that should be also 1450 that I have calculated.